Howdy, this is Julian Garza,
I'm Jackson Barnes.
Walker Gerard.
I'm Chris Hunt.
And Matt Wesp.
and this is a presentation on our hydrographic survey of Aggie Park Lake. With the building and opening of Aggie Park Lake in late 2022, a problem came up about the soil that was used for the construction of the lake. The management for the lake were wondering if the soil would be susceptible to erosion after a long period of time. To track this erosion, our group used a kayak that had a Lawrence hook attached to it to record points of the lake bed, and this was done while navigating in a specific route to ensure that we are collecting data from the entire lake. Our group obtained the topography and elevation of the bottom of the lake, and this was resourceful as we can create a shapefile that can be used to inform the faculty and the College of Arts and Sciences about the quality of the lake floor and banks. This presentation will discuss side scan sonar, global navigation satellite systems, GPS, and its use for conducting a hydrographic survey of a body of water.
Coming into this project, the original idea was to use the RC boat shown in the upper right images to map the lake bed, but due to multiple failed trials with technical difficulties surrounding the boat's battery, we ultimately decided on using a kayak after collecting mappable data on the kayak's third trial run at the cove location shown in the left-hand images. With the other two kayak trials yielding no data on the first run due to Lowrance transducer not sitting low enough in the water and excessive drag from an unbalanced design, and the second trial collected some data, however the battery and the Lawrence display died, we ultimately decided after the third successful trial run to solidify our decision and utilize the kayak for the final test at Aggie Lake.
We made a rig of 2x4 planks and survey stakes on our kayak to hold the transducer and its display. We first sent the 36-inch plank through the handle on the front of the kayak. Then we placed the 24-inch plank and 69-inch plank underneath it to hold it in place and screwed them together. The pressure from the front handle pushing down on the stacked planks was enough to prevent the rig from sliding front to back, but it still wobbled from side to side. We applied duct tape to the planks to stop this. We screwed on two of the 12.5-inch planks on each side. We added two instead of one so that the center of balance would not shift to the side and to prevent one-sided water resistance. The Lawrence 5TS display was screwed onto the 69-inch plank. The Lawrence triple shot skimmer transducer was zip tied onto the 12.5-inch plank. The transducer battery cord was taped to the 69-inch plank to prevent it from getting snagged. Though you cannot see it in the figure here, we wrapped the battery in a towel and placed it in a shopping bag.
As for the procedure, once the kayak was rigged as Jackson described, we conducted a series of trial runs at the pond at the cove location. We ran these tests several times and on different days so that we could become familiar with the equipment we were using, that being the Lawrence Hook 5TS and the Lawrence triple shot skimmer transducer. As we saw fit, we also changed anything that we needed to change in order to guarantee the best possible outcome for the survey. The data we collected from these trial runs can be seen in the bottom left figure, and the final kayak rig can be seen in the top right figure. On the day we actually went to go survey Aggie Lake, we had flags that would act as turning points spread around the lake roughly every 5 feet. We eventually came to find out that we didn't have enough flags, so we had a group member on each side of the lake marking to the kayaker when and where to turn in order for the kayaker to maintain a consistent route and to ensure that we were gathering complete data. Once everything was set up, we placed the kayak at the northern end of Aggie Lake, just off of the amphitheater, and once we were good to go, the kayaker began a snake pattern around the entire lake. After the full snake pattern was complete, the kayaker also performed a full loop around the lake to ensure that no data was missing from the sides of the lake. You can see the snake route pattern and the post-route loop in the figure at the bottom right of this tab.
The two softwares we used were the ReefMaster and Field Map softwares. We used Field Maps to make a polygon to create a boundary of the lake. We then ported the polygon into the ReefMaster software. We had used Field Maps due to mapping softwares like Google Earth Pro and ArcGIS Pro not having updated aerial and satellite imagery that showed the lake. In the ReefMaster software, we created a depth map in both 2D and 3D and also we're able to study the sonar downscan data directly. An interesting little bit of information is using the equipment and software, you can actually see the fish that pop up on the sonar data while testing. We created 2 depth maps. One is in 2D and the other is in 3D. The depth is shown using contour lines. The major contour lines are recorded every 1 US feet, and the minor contour lines are recorded every 0.25 US feet. The depth map is color-coded, with red being more shallow and blue being more deep. As you can see, there's 3 deeper sections of the lake, with the deepest being roughly 14 feet. 3 objects were found in the lake using the sonar data. These 3 objects are at different coordinates on the lake, but are roughly at the same depths, with those depths being around 12 feet. This is shown by the blacked out area on the 3D base map below. Our best guess is these objects could be VOs thrown off the bridge or chairs knocked in by the wind or students. There's really no way to tell what these objects could be unless they're fished out by the park caretakers and former Students Association.
This project served as an important role, laying the groundwork for future groups that conduct this survey, providing them with baseline plans as well as a template for how to assemble the sonar, and demonstrating how this technology can be applied to other bodies of water outside of Aggie Lake. Future scans will be vital to ensure underwater erosion does not worsen over time, as well as allowing the university to come up with plans to prevent or counteract the erosion if it progresses. Most importantly, though, this experiment started a fun tradition that will continue yearly while bolstering Aggie camaraderie. Thanks, and gig 'em.